All right, today this is just 1.5, just odd examples and extra notes in case you're lost when I'm not there today. So if you can understand how I'm doing these odd examples, the even problems that you're going to be assigned are going to be extremely similar. So you're going to use these same concepts to do the odd examples, or to do the even ones. Now, just to clarify what we went over yesterday, the big ideas is that a radical is simplified. A radical is simplified when there are no perfect square factors so you can't divide a number inside the radical by a perfect number, and you're never allowed to leave a radical in the bottom. Now, remember, for this assignment, for part 1, no decimals or rounding. You will get 0 points if you round or use a decimal, so don't do that. Don't just plug it in your calculator. You're not allowed to do that. Now, with conjugates, there's 2 types of conjugates. Now, remember, conjugates are always pairs. All right? So conjugates, if you see a radical all by itself, the pair is just the same exact radical. If you see a radical that has a number with it, so it could be any number, then the conjugate is the opposite sign. So if you have a minus in the middle, your conjugate is going to be a plus sign. We're going to use conjugates when we're rationalizing the denominator. All right, we'll talk a lot about that in a little bit. All right, so number 3 is on the whiteboard. So if you're not, I actually already did this all out, but now I'm going to explain it. So radical 28, I have one radical. The number inside 28 is not perfect. 28 is not perfect. But I can write the factors of 28 as 1 and 28, 2 and 14, 4 and 7. Only one of these factors is perfect. 4 is a perfect factor. So I'm going to rewrite 28 as the square root of 4 times 7. Now, you're going to look at these 2 numbers. If you're perfect, you're allowed to leave the jail. If you're not, you have to stay in jail forever. So I call the radical a jail. And if you're perfect, you get to leave the jail. If you're not perfect, you have to stay in. So 4 is perfect. Now you have to remember the square root of 4 is 2. So when 4 leaves the radical, it comes outside as 2. 7 is not perfect. It stays in the radical as 7. So your final answer is 2 radical 7. All right? This is the most simple version of radical 28. Radical 28 and 2 radical 7, they're the same exact thing. They just look a little bit different. 2 radical 7 is simplified. Now, I don't like going through all the factors of 150 individually because I just think that takes a little bit too much time. So what I do is I just use the perfect square factors that I know. So I know the perfect square factors. I know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and I keep on going. 9 squared is 81, and this is on the whiteboard in red, the top left corner of the whiteboard. 10 squared is 100, 11 squared is 121, 12 squared is 144. That's all I need for this. So 150 is not on this list. So I start going through this list. I start at the bottom. I just start dividing. 150 divided by 144 is a fraction, so it doesn't help me. 121 doesn't help me. 100 doesn't help me. I just start dividing. Every time I get a fraction, I get a decimal on my calculator, I move on to a different number. 150 divided by 64, it's a decimal. 150 divided by 49, decimal. 150 divided by 36, decimal. 150 divided by 25, that works because 6 times 25 is 150. So I'm going to rewrite the square root of 150 as 6 times 25. Now 25 is perfect, so he gets to leave the radical as 5. And 6 is not perfect, so he stays in forever. And that's it. That's all you have to do for 5. So if you have one radical, you just start going through your list of perfect numbers and finding a perfect number that divides into the number inside the radical. And then once you break it down, the perfect number, the square root comes out, and the non-perfect number stays inside. That's it. Number 7 is 4 radical 6 times radical 6. So here's one thing you want to remember. If you see multiple radicals, you can combine radicals using the product property. So the way I think of it as, if guys are in jail, both 6 and 6 are in jail, you can multiply them together. So 6 times 6 stays in jail as the square root of 36. So these two radicals right here turn into square root of 36. 4 is out of jail, so he has to stay out of jail forever. He's not allowed to go in. Right? The only time you're allowed to leave jail is if you're perfect. Well, 36 is perfect. So this whole thing, the square root of 36, turns into 6. So 4 times 6. If everything's perfect, the radical just disappears. So your final answer for this one is just 24. Because the radical disappeared because 36 was perfect. That's it for 7. Alright, number 9 is the square root of 5 over 16. Now, because it's a fraction, I don't want to mess with 5 and 16 as a fraction. So I'm going to take the radical to the top and the bottom. So if you ever have a fraction inside the radical, you have to split the radical up. So the square root of 5 over the square root of 16. Now I just do everything I did before. I look at radical 5. It can't be broken down. Well, 16 is perfect, so the whole thing turns into the square root of 5 all over 4. This is simplified because there's not a radical on the bottom, and there's no perfect number that goes into 5. So that's it. Number 11, I have 8 over radical 3. This is not simplified because there's a radical on the bottom. So remember, you're not allowed to have a radical on the bottom. So I need to get rid of this radical 3. Since it's only a radical on the bottom, it's that first type of conjugate. So the conjugate is just a radical by itself. So if you want to have a radical by itself, you are going to multiply by that exact same radical. So I'm going to multiply by the square root of 3. Now here's the issue. When you multiply something in a problem, the only number you can multiply has to be 1. So you must multiply by 1. Alright? 1 is equal to any fraction where the top and the bottom are the same. So if the top and bottom match, you're multiplying by 1, even though it doesn't really look like 1. So I made up this radical 3 because it's a conjugate. So those are conjugates. But I have to put a radical 3 on top. So this right here, this new thing that I added, I made it up out of thin air, it has to equal 1. And it does. Now I can multiply it. And remember, I am multiplying by 1, so it's not going to change the value. It's an equivalent fraction. Just like 1/3 is the same thing as 2/6. Those are equivalent fractions, right? So when I multiply this, I'm going to get an equivalent fraction. It's going to be 8. I'm going to multiply the top together, 8 radical 3, all over the bottom. Well, radical 3 times radical 3. Both those guys are in jail, so that's radical 9. When the square root of 9 is just 3, so it becomes 8 radical 3 all over 3. So that's it. All right. Now, with a lot of these problems, there's a couple different ways to do all these problems. So you might, on your own, do this number 13 a little bit different than I am, and that's okay. As long as you get the same answer, you're not doing anything wrong. If you get something different, then yeah, you are doing something wrong. But the first thing I'm going to do is I'm going to break up radical 18 all over radical 11. I'm going to take that radical that's outside a fraction, I'm going to take it to the top and the bottom so I can look at them separately. Now, right away, I think to myself, I don't want to have that radical in the bottom. I don't like that, right? So I'm going to multiply by the conjugate radical 11. So the conjugate of, since it's only a radical on the bottom, I multiply by the exact same radical, because that will make the radicals cancel out. Because remember, radical 11 times radical 11 equals the square root of 121. Well, 121 is perfect, so that's just 11. Now, I'm only allowed to do that if I make the top match. Because remember, whatever I made up, this red box right here, I made it up. It has to equal 1, or I'm changing the value, and that's against the rules. So, I'm going to multiply by the top and the bottom. Both 18 and 11 are in jail, so I multiply those two together to get 198. Radical 11 times radical 11, I just showed as 11. Now, you can't stop here because 198 is not a simplified radical. So, although it satisfies the one criteria about not having a radical on the bottom, 198 is not simple. There is a perfect square that goes into 198. So if you're not sure what to do, you just list all your perfect squares and you start dividing. I'm going to tell you 9 goes into 198. So I can rewrite 198 as 9 times 22 all over 11. Now 9's perfect, so he gets to leave jail. 22 isn't, so it becomes 3 square root of 22 all over 11. And that's your most simple answer. All right? If you got this far, you know, that's probably, it's like half credit. You did half the work. But this is your final answer right here. All right? And that's it for 13. Now 15 is going to use that other type of conjugate, where you have something with a radical. So the bottom is 1 minus radical 3. So I can't multiply by just a radical anymore. I'm not allowed to do that. So this is the new concept. So a lot of us will probably struggle on this. That's why really pay attention to how I'm doing this. All the radicals are simplified, so I don't have to worry about that. The only issue, the only rule that's being broken is there's that radical in the bottom. If I just multiply by radical 3, it won't make the radical disappear. So whenever I see a conjugate, right, whenever I see a radical, I got to think conjugates. So I have, we're going to say A minus radical B right here. We're going to call this a number minus a radical. So the pair that I'm going to create is the same exact thing, but I put a plus sign in the middle. I just switch the sign in the middle. So I always make the conjugate first. I write the bottom first. So I have 1 minus radical 3, so I put 1 plus radical 3. I created this. This is my creation right here. So whatever you create, if the top and bottom don't match, you're breaking a rule. So I have 1 plus radical 3. I have to write 1 plus radical 3 on the top. And that makes this whole thing equal 1. So that's a good self-check you can do on 15, 17, any problem where you're multiplying radicals to make them disappear. If the top and bottom don't match on what you're multiplying by, you're probably doing something wrong. So now, I'm going to multiply across the top and multiply across the bottom. It's a little bit harder because I have to distribute the top. 2 times 1 plus radical 3. So I have to distribute that 2. And the bottom is actually going to be FOIL. 1 minus radical 3 times 1 plus radical 3. So even though there's not a letter involved, you're still going to use FOIL just like we did before with x's and numbers. So the top's pretty simple. I just distribute the 2. I get 2 plus 2 radical 3. Now the bottom I have to FOIL. So I do the first 2. 1 times 1 is 1. I do the outside. That's plus radical 3. I do the inside. That's minus radical 3. I do the last 2. Radical 3 times radical 3. Well, that's minus 3. Because it's minus radical 3 and plus radical 3. That's why the radical 3 and radical 3 give me the 3. The minus times the plus give me the minus. Now here's the interesting part, and this is why they're called conjugates, is when I FOIL the bottom, those radicals in the middle cancel each other out. So I'm left with 1 minus radical 3. That doesn't have a radical in it. It's really easy to do. You just do 1 minus 3. It's negative 2. So 2 plus 2 radical 3 all over negative 2. If you got that far, you did all the new stuff correct. So the only mistake, not a mistake, the only thing you have to do left is you have to realize 2 goes into all of them. They all share a 2. So I can divide everything by 2. 2 divided by negative 2 is negative 1. 2 divided by 2 is negative 1. So it's negative 1 minus radical 3. That's your best answer. I would probably take that for full credit on a quiz. Alright, 19, I have radical 2 over 4 plus radical 5. Right away, I know I'm going to be using conjugates because I see a fraction. I see a radical in the bottom. I know I'm going to use my second type of conjugates because I'm going to have a plus radical b on the bottom. So that means I'm going to make a minus radical b show up. So the first thing I'm going to do is I'm going to make I want the conjugate of the bottom. So I need to make a conjugate show up. Because one thing by itself is not a conjugate. Conjugates are always in pairs. So the conjugate is 4 minus radical 5. So that's the easiest thing to do, is to make the conjugate. The most common mistake that people do is they forget to make this 4 minus radical 5 on top. I see all sorts of stuff on top. I see radical 2 on top. I see 4 plus radical 5 on top. Here's a good self-check. Whatever I create, 4 minus radical 5 over 4 minus radical 5 is not part of the problem. I made it up. Whatever you create has to equal 1. Or in other words, the top and the bottom have to match exactly. So now I can multiply across the top. I have radical 2 times, in parentheses, 4 minus radical 5. The bottom turns into 4 plus radical 5, 4 minus radical 5. I'm going to use the distributive property on the top. I'm going to FOIL the bottom. So the top, I'm going to distribute. I'm going to have radical 2 times 4 is 4 radical 2. Radical 2 times negative radical 5 is minus radical 10. The bottom, I have to FOIL, so I do 4 times 4, 16. The outside is minus 4 radical 5. The inside is plus 4 radical 5. Notice, when you multiply somebody who's out of jail and somebody who's in jail, they just stand next to each other. You can't put the 4 times the 5 together because 5 is in jail, 4 is not. They cannot be multiplied together. They just go right next to each other. And radical 5 times radical 5, well, that's radical 25, and then the minus sign right there makes it minus 25. Now notice, because these are conjugates, the middle terms cancel out. So I just get 16 minus 25. So my final answer is 4 radical 2 minus radical 10 Remember, this is the square root of 25. I must have forgot to put that radical in there. So it's 16 minus 5, because the square root of 25 is 5, which becomes 11. Right? And that's it. So just remember, most of the time, you're always going to look for perfect square factors. So don't forget perfect square factors. And the numbers are on the board. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and you can keep on going. You could do more if you want more. I always start at the biggest number and then work my way down. So that's one thing. So the other thing you're going to have to remember is conjugates. Alright? Conjugates, if you have a radical all by itself, the conjugate is the same exact radical. If you have a plus radical b, the conjugate. So, just remember perfect square factors. The factors are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. If you're not sure something's a factor, grab a calculator, take the number inside the radical, divide it by one of the numbers on this list. If it works out nicely, it's a factor. If it gives you a decimal, it's not a factor. Move on to another one. Conjugates. If you have one radical, the conjugate is always the same exact radical. If you have a number plus a radical together on the bottom, your conjugate's the same thing but with the opposite sign. So if it's a plus radical b, you have a minus radical b. A minus radical b, a plus radical b. All right. Don't forget, no decimals or rounding. So you can't just throw it in your calculator and just pretend like the decimal never existed and just pretend it's, a whole number answer. So there's no decimals or rounding. All right. Remember, if you create anything that we make up, anything, you make up to multiply, it must equal 1. And that, remember, that means the top and the bottom have to be the same. That's how you know something's equal to 1. It doesn't have to look like 1. The top and the bottom have to be exactly the same. All right? As long as everybody behaves, this should be due either Friday or Monday. So if you have any questions, just do your best. And the only way you can be wrong in this homework assignment is if you just throw it in your calculator or you don't try. So have a great day.